Hello there students, welcome to this optimization lesson where I'll be presenting a problem based on volume. Remember, optimization is a process whereby we minimize or we maximize quantities, and we usually follow differential calculus means to successfully do so. What is the question? Take a look. Okay, so let us make this situation practical, all right? We have a right angle triangle, and I'm going to use a t-square in this case. And what are we doing? We are rotating it on a horizontal surface, suppose, so that we can form a cone, all right? So this is what's happening, and we end up going from here to there, okay? And as you've seen the question, we want to calculate the maximum volume. What is the keyword there? Maximum. So that gives you the idea that you need to optimize this quantity called volume. If the question was saying calculate volume, that is just your straightforward standard question of calculating volume through the formulas that by now you know of different 3D objects. But whenever you see minimize or maximize, you understand that you need to optimize. Okay, let's look at it. What are we doing? We are moving from this right angle triangle. Through rotation, we are forming this cone, and we are asked to calculate the maximum volume that will result through this type of transformation, if you like. What are we given? We're given the length of AC, and you definitely see that that is also 10 square root of 5 centimeters, and we're given the length of BC, and in a cone obviously you have a center. In this case it will be BC, and therefore BC will be what for us? It will be the radius, okay? And it is given as an algebraic expression, 475 minus 10x minus x to the power of 2, all in brackets raised to the power of a half. And what does the half indicate for us? Definitely a square root. Okay, so we need to be very careful here and delicate in the manner in which we go about doing this or solving this problem. Okay, we are given the formula of the volume of a cone, 1 over 3 pi r squared h. Right. What is the height? The height is represented by AB, and look, there is your height of the cone. That will be h as well. Okay, so we need to be able to link different information items to the sketch, to the diagram, so that we can build, the picture of how the solution should look like. That's what we know. Because there's a right angle triangle and 2 dimensions are already given, can we find a third side? Yes. How? I hear theorem of Pythagoras. Good. So that is the most obvious thing to start with, which is straightforward. However, as I said, we need to be careful with this guy right here. Okay. So in triangle ABC, what is happening? H, the square root of AC square minus BC square will definitely give you H by theorem of Pythagoras. Okay, what do we then need to do? We need to substitute the square root of 10 square root of 5 square minus BC. It's a long expression. Okay, so we need to be careful there. 475 minus 10x minus x squared, okay? And this is under a square root. And what are we doing? We are squaring this. And all of this is under the bigger square root. Good. Let us simplify now. What are we having? What's going to happen here? 10 squared is 100. cancellation of the square root and the square to 5 there will remain. So you'll have 500 minus what? The square and the big square root, not the big square root here, the smaller square root. This expression will cancel out. And what are we remaining with? 475. The distribution of the negative sign there plus 10x. Distribution of the negative sign plus x squared, and all of this is under a square root. Okay, now we clean up. What do we have now? Square root of, let's write it in standard format, your leading term first, x squared plus 10x. 500 minus 475 is what? 25, right? 25. Okay, what do you notice about this trinomial? The square is complete, yes? So we rewrite it like that. X plus 5, okay, square. The square is complete. So then what do we notice? Cancellation happens, and therefore h is equal to x plus 5. Okay, this will now be expression, and this side as well, that will be your expression for h, or the height of the cone. Okay, so from a complex situation, we managed to use, basic mathematics to move to a more simpler expression of the height. Okay, so now we are ready to bring the height into the volume formula, okay, and also to take the radius into the formula. And we see that everything will be in terms of one variable that will allow us to differentiate, and by so doing we maximize this quantity called volume. Okay, so this is where we are now, and we are ready to proceed with finding the maximum volume of this cone. So the substitution will take place for both R and H into the formula itself. So then we produce a volume function with respect to x, where everything now will be in terms of one variable in the expression of the volume of the cone. Right. So the R is the expression 475 minus 10x minus x squared. Okay, and remember, all of this is under a square root, and what are we doing? We are squaring the R. We are multiplying this by the height, x plus 5. Clearly we can see the square and the square root disappearing, and then we have 1 over 3 pi. What is left? 475 minus 10x minus x squared times x plus 5. Right? We need to clean up and obviously perform distribution there. Okay, so I'm just going to come this side. We have 1 over 3 pi what? 475x, right? And then we multiply with the 10 minus 10x squared minus x cubed, right? And then we go to the 5. 475 times 5, we get 2375, and then minus 50x minus 5x squared. Right, so that is where we are, and we definitely need to check what are the like terms in this case. 1 over 3 pi. Okay, so this guy with that guy, right? So 475 minus 50 gives us 425x, right? And then negative 10x squared, negative 5x squared, negative 15x squared, minus x cubed plus 2375. Okay, and there are no more like terms. So this is our volume function with respect to x. So for max volume, what do we know? V prime of x is equal to 0, right? So there's a constant multiplied by some function, and this function is a cubic function. See, the leading term is it has a power of 3. So therefore, we need to differentiate. Let's find the first derivative. We can leave this outside. V prime of x is equal to what? Let's have the first term there differentiated. It's going to be 425 minus 30x minus 3x squared. Yes, that is a constant. It falls away. And we're saying this is equal to 0, right? So what's going to happen? We can divide both sides by 1 over 3 pi, so that that and that guy goes away, and we simplify the expression, and that will remain as 0 on the right hand side. Okay, so we have written our derivative expression here in standard format. It's equal to 0, and we need to solve x, right? We can go straight into the quadratic formula, and we have x equal to negative b is going to be 30 plus or minus square root of negative 30 square minus 4 times a, negative 3 times c, 425. Okay, all over 2 times negative 3. You plug this into your calculator, okay, and you check what you get. Let's practice that. 12, 425. Okay, the first answer I'm getting is x is equal to negative 17.91, and I use 2 decimal places in this case, or x is equal to, let's get the other solution, 7.91. Okay, now let us check which one is acceptable and which one is not. And let's recall therefore our volume equation. 1 over 3 pi 475 minus 10x minus x to the power of 2 times x plus 5. That was the expression of our volume function, right? And if you substitute this one in there, you'll get a negative value, and we're dealing with volume. It's always a positive quantity. So therefore we reject this one, okay? And which one is acceptable? That one, okay? So therefore we understand that x is equal to 7.91. It is what we're going to substitute there. So what will go there, what will go there, and what will go there, okay? So therefore maximum volume happens when we are at 7.91, okay? And we just substitute 1 over 3 pi 475 minus 10 times 7.91 minus 7.91 squared, okay? 7.91 plus 5, okay? You plug that into your calculator. Let us see what we get. 5 minus 10 times 7.91, okay, minus 7.91 square, 7.91 plus 5, 4,506.42 cubic centimeters. Students, this brings us to the end of this interesting problem, and I believe that you have enjoyed it. I mean, if you've watched the video to this point, it means you have been following, you have been actively working that side as well, and seeing that what I'm doing here makes mathematical sense, and it helps you to, approach these difficult problems with a more courageous and confident spirit, knowing that, you have the maths, you have the tools, you have the keywords, you understand how to link information items and given information into sketches, into diagrams. Sometimes you can also visualize, as we have seen with the t-square. Remember in the beginning, I showed you with the ruler. It's a mathematical instrument that, that's what we're doing. We are rotating it to form this cone of which we are finding the maximum volume form. All right. So it's very important that the crux of optimization is you knowing how to form the formula or the equation that you need to derive. Without that, it's impossible to arrive at the end result, which is the answer to the maximized quantity or a minimized quantity. All right. So thank you for tuning in. See you next time. Go out there and excel. Sharp, sharp.